Hello guys, welcome back to this new video on my YouTube channel. So in today's video, we're going to be solving this question that was sent to me by a student here in Douala. Yes. So without wasting much of your time, let's just go into the question directly. So the question read: a line L meets the curve y equals to x cubed minus 6x plus 10 at the point A, B as shown in the diagram above. So basically, this is the diagram here. As you can see, this is the figure, this is the point A and this is B, then this is the line L. This line is L, this is the line here. The coordinate of the point B are B, comma B. That's the coordinate of this point B, where B is not equal to 2. That's B is different from 2. Okay. So the first question says, state the coordinate of point A. Then the next question is, show that B is equal to 5. C, find the equation of the line L passing through the point A and B. Then D, show that the distance between A and B is 5 or 2 units. Now the last question we have E, we are asked to look for the area, as calculate the area of the final region R bounded by the curve, bounded by the line and the curve. So this was all about the question. And as we all know, the solution is already there. I'm just going to explain. So the first question says that we should look for the coordinate of A. This is A, that we just state, meaning that we're just looking at the answer. This is point A, right? So at this point, we realize that the y coordinate at this point is 10. Then the x coordinate is is still at the origin, that's 0. So basically the point A should definitely be 0, 10, because we write the x coordinate first before writing the y coordinate. Hope that's clear. Okay, then they say we should show that b is equals to 5. Okay, for us to show that b is equals to 5, right? That is remember at this point, that's point B, because remember the coordinate of B is B comma B. So I have to show that the coordinate of B is just 5 comma 5. So for us to show it at this point, what we will do is that at this point we realize that the line and the curve do intersect at this point. So the x coordinate of the line and the x coordinate of the curve at this point here are the same. So that's the idea that we're going to use to solve this question. But now there is an issue. What's the issue? The issue is that we don't have the equation of the line. You see, so what we do is that since you are required to show that b is equal to 5. Now you know that at this point B, the coordinate are b comma b. Meaning that the y coordinate is b and the x coordinate is also equal to b. And remember I said at this point, if the y coordinate is b and the x coordinate is also b, it will mean that when we substitute b on this equation, it must satisfy this equation. That this equation of the curve. Yes. Remember the first approach was that we are going to equate the equation of the line and the equation of the curve, but we don't yet have the equation of the line. So the second approach is that since b lies on this curve, it will mean that point B satisfies this curve. So when we input b, mean that when we replace y with b and x with b, it must satisfy this condition, this equation. So if you do that, we are going to have b is equals to b squared minus 6b plus 10. Remember we had y equals to x squared minus 6x plus 10. And if you bring like them together, we are going to have b squared minus 7b plus 10 equals 0. And we can easily factorize this. Remember this is a quadratic equation in terms of b, so you can factorize it. The factors are going to have b minus 2 and b minus 5 equals 0. So b equals 2 or b equals to 5. So these are the two solutions of B. But now we already know whenever we're having a quadratic equation, so we should definitely have two solutions, as b equals 2 and b equals 5. So from here now we have shown that b is equals to 5. Now the question is the other value of b, other value of b. Now the thing is, at this point, right, b is equals to 5. Yes, we are okay at this point. B is equals to 5, meaning the x coordinate of this curve, as the x coordinate of this curve is equals to 5 at this point. Are you see now? Yes. Now the next question says find the equation of its line L passing through the point A and B. Okay, we are required to look for the equation of the line passing through the point A and B. We are taught how to look for equation of a straight line passing through 2 points. The general formula will simply be this. Uh, okay, equation of the line. This is point A and this point B, 5,5. Perfect. So we already know this equation. That's y minus y is equal to m into x minus x0, where m is the gradient, that's the y on the x, the gradient. But now the gradient will be gotten by just taking 5 minus 10 divided by 5 minus 0. This is 5 minus 10 is dy, that's change in y. That's y2 minus y1 divided by x2 minus x1. Initially, this is my x1, y1, then x2, y2. It doesn't matter whether you choose this one to be your x1, y1 and your x2, y2, but just that you have to respect this order. Yes, you have to respect the order. If you do that, you are going to have your gradient to be minus 1, as the gradient of the line to be minus 1. So just must substitute everything. You have y minus 10 is equals to negative 1 into x minus 0, because remember x0 is x1, that's equals to 0. Then the equation of the line will simply be y is equals to negative x plus 10. You can arrange it if you wish, but I would prefer to leave it like that. Yes. Now the next question says, let's see, find no D. Okay, show that the distance between A and B is 5 or 2 units. Now we are asked to look for the distance between these 2 points. Distance between 2 points can be gotten using the formula D is equals to the square root of x2 minus x1 other squared plus y2 minus y1 other squared. Or you can simply take this D is equals to x minus x0 squared plus y minus y0 squared. Yes, depending on you. Remember our x is 5, then now the x0. Now this x can still be x2 minus x1. See now, yes, so it doesn't matter which one you are using, but here it's just that you use x0. And I mean that this is my x1. See, so if you do it correctly, you're going to have 5 minus 0 other squared plus 5 minus 10 other squared. And here you're going to have 5 squared plus negative 5 squared. And the answer will be 2 times 5 squared. And the final answer will be 5 with 2 units as required. So this is just how I came up with the answer. And it shows that the proof is really going. So now the last question, we are asked to find the area. Now, whenever we are asked to look for the area of two curves, remember this is a straight line and this curve. Whenever we are asked to look for the area of these two curves, when they intersect, right, what we do is that we are simply going to look for the point of their intersection. As the point of the intersection, this point and this point. We are simply going to look for this point. Then now the area will simply be the integral of the difference between the two curves. So that is why I wrote here. Okay, that's why I wrote here. Area is equals to the integral from x0 to x of YL minus YC. YL simply means the line, that's the equation of the line minus the equation of the curve. Now, x0, this I remember these are the point where these two curves meet. They meet at point B and point A. And at point A, the S coordinate is 0. Remember, it's at the origin. And at point B now, the S coordinate is 5. Remember B was 5, so the S coordinate is 5. So that's why we're integrating from 0 to 5. Yes. And now this was our equation of the curve, of the line. Negative x plus 10. Then now the equation of the curve, x squared minus 6x plus 10 is x. If you open this bracket, you realize that 10 minus 10 will disappear. And you play with negative x squared, negative x squared. Now negative x plus 6x will be 5x. Now if you integrate x squared, negative x squared, you have minus x cubed on 3. And if you integrate 5x, you have 5x squared on 2. The boundaries are from 0 to 5. The lower boundary will definitely be 0 in the upper, so we are concentrated only on the upper boundary. Upper boundary, when you substitute 5, you have 125, negative 125 divided by 3 plus 5 squared is 25, 25 times 5, 125 divided by 2. And if you do this, you're going to have your area to be equals to 125 on 6 square units. So that was just all about the exercise. Yes, realize that those who even solve this mock, it is not even stress to answer these questions because they're just direct. Yes. Okay, guys, thank you guys for watching, and see you in the next tutorial. Stay blessed.